Welcome to This Explainer. Today we're diving straight into Wolf Call's breakthrough research on the institutional governance of decentralized AI agent systems. We've got a super focused topic today, and it is becoming incredibly relevant as AI moves out of the cloud and directly onto our local devices. We all kind of assume that local AI means total control, right? But does it really? To answer that, we're going to unpack the 6 critical requirements for true autonomy. So let's kick things off by challenging a massive assumption. The idea that just because your AI runs on your own hardware, you're perfectly safe and entirely in control. We're moving fast into this era where models, agents, tools, and data all compose together right there on your local machine. So imagine you've got a local workflow involving 3 different AI agents, and suddenly they improperly spend your money. How do you know which one actually pulled the trigger? Well, here is our roadmap to figure that out. 1. We'll look at the custody illusion. 2. The accountability gap. 3. The 6 requirements for autonomy. 4. A reality check on a live system called Mosaic. And 5. Engineering the fix. Let's get into it.
Starting with Section 1, the custody illusion. Why sovereignty is not enough.
For a decade now, the absolute biggest problem in tech was custody. Who holds the data? But that is fundamentally changing. Think of it kind of like an office building. Sovereignty means you own the building and you lock the front door. Nobody from the outside gets in. That's great. But accountability? Accountability means knowing exactly which of your employees inside the building just broke the printer. Moving execution to your local device totally solves that custody problem, but it completely fails to answer who is responsible when multiple agents interact. Now, when you combine these 4 properties, you create a wildly powerful new class of system known as a sovereign local agent runtime. You've got local execution, you hold your own state, you have multiple independent agents working together, and this is the fascinating part, this includes machines literally spending money, autonomously paying other machines for services. But here is the catch, and it's a big one. A system like this desperately needs common rules for coordination, because just having connectivity is absolutely not the same thing as coordination. Which brings us right to Section 2, the accountability gap, where local systems break down. A lot of times, we talk about vague trust issues with AI, but those actually break down into 4 highly specific diagnosable failures. First up is attribution failure. Basically, you get a wrong answer from a multi-agent workflow, and you have literally no idea which agent messed up. Second is authority drift. This is when an agent holds on to data permissions long after you actually intended. Third is evaluative capture. Think of this as agents getting hired based on totally fake, manipulable, self-reported scores. And finally, the recourse vacuum. When an outcome is wrong, you have absolutely no defined path to challenge or fix it. All right, Section 3. 6 requirements for autonomy. The institutional bedrock. To fix those gaps, we need these 6 testable requirements. They are essentially the holy grail of local AI. They form the absolute minimum institutional layer we need before we can safely let agents act on our behalf at machine speed. Without these, you just have chaos. So, you need separation of reputation from access, durable provenance to track history, true downward revocation so you can pull the plug, ungameable valuations, clear value attribution for payments, and actual contestability to dispute those actions. Let's zoom in on the first one, because it's a real game changer. Reputation can definitely help your system decide which agent to hire, but it should never, ever function as a security badge to bypass enforcement boundaries. If a highly reputable AI gets special access privileges just based on its score, well, you've just incentivized massive manipulation. If having good standing automatically opens a locked door, you're turning a simple performance signal into a massive security risk. And looking at requirement 2, this is just as crucial. True provenance isn't just live telemetry monitoring what's happening right now. It's a durable record that a third-party auditor can actually read later. Think of it like a digital crime scene. If 3 agents complete a task and then shut down, an auditor needs to be able to piece together exactly who did what and on whose authority. That record has to survive even after the workflow completely finishes. So, how does this look in practice? Let's go to Section 4, Reality Check, Mosaic, where we evaluate a live system. How does a cutting-edge local AI system actually stack up against these requirements today? Well, while the Mosaic platform correctly treats tools as low trust, which is fantastic by the way, the reality of auditing it is a bit messy. Right now, different tools generate completely disconnected locks. There's no single workflow ID connecting them all together.
It is literally just a bunch of timestamps. So if something goes wrong, reconstructing that digital crime scene we just talked about is basically impossible. And honestly, it gets a bit more concerning. Even though basic sandbox tools write logs, the critical connective tissues, like built-in modules, currently write nothing at all. And the payment plugin? The part of the system that intercepts network responses and moves real, actual financial value autonomously from machine to machine, it writes nothing into any log. You literally have real value moving around with zero durable record of which component actually earned it. But don't worry, there is a solution. Section 5, Engineering the Fix, Minimal Modifications for Accountability. The beauty of Kyle's research here is that it proposes minimal, actionable tweaks to the existing code. We don't have to rebuild the entire system from scratch. By simply minting a shared workflow ID that threads through every single tool's log, you aren't just guessing based on timestamps anymore. You can pull every action related to a single task instantly across all participating agents. It turns cross-component correlation from complete guesswork into mathematically verifiable selection. Implementing this really just takes 2 precise steps. Step 1, you add the trace context. This means the core system mints a workflow ID, so we know exactly who is doing what, tying all those separate actions to one single ID. Step 2 is hash chaining. See, because the local log is just a file sitting on your computer, a compromised tool could theoretically just hit delete and erase its bad behavior. But hash chaining makes any cover-up instantly obvious. If an AI goes rogue and tries to delete its tracks, the cryptographic chain is broken at a highly specific point, alerting you immediately. It is totally tamper-evident.
I want to leave you with this provocative thought today. As autonomous agents start taking over our local machines, if you don't demand these 6 requirements for autonomy, you are essentially letting someone else write your rules. Custody of your data? Sure, that's a great start. But true accountability is what will actually allow us to trust these local agent ecosystems at scale. Thank you so much for joining me to explore this fascinating and absolutely essential framework for the future of AI. Catch you next time.